The clever calc spider climbed up the curve, searching for extrema with a keen nerve. Down came the derivatives and the list began, seeking peaks and valleys with a cunning plan. Out came the critical points where changes occur, candidates for maxima and minima to infer. The spider evaluated with sign chart. First derivative test, a crucial device. If positive to negative, you have a maximum. If negative to positive, a minimum you have. The spider explore intervals with great care, identifying local extrema lurking there. The second derivative test the spider used, confirming concavity where solution soaked. Positive means a minimum concave up, negative means a maximum concave down.
Calculus, calculus, functions high, derivatives we multiply. Limits show us where to go. Integrals reveal what's below. Calculus, calculus, functions high, derivatives we multiply. Derivatives are primary tool, slopes of curves, rates that rule, product power chain rule, quotient rule, a baseball bat to kill a fly. Calculus, calculus, functions rule, slopes of curves, rates that are great. Integration, the next frontier, area under curves so clear. Antiderivatives we seek to find, definite integrals, bounds defined. Integration, the next frontier, area under curve so clear.
Optimize all day, optimize all day, optimize all day. The wheels on the bus optimize all day, maximum, minimum, all the way. The bus's speed goes fast and slow, fast and slow, fast and slow. The bus's speed goes fast and slow. ABS of velocity, rate of change of velocity goes up and down, up and down, up and down. Rate of change of velocity goes up and down. Related rates, here we go. The engine's power, it roars and hums, roars and hums, roars and hums. The engine's power, it roars and hums, increasing velocity. The bus accelerates faster and faster, faster and faster, faster and faster. The bus accelerates faster and faster. Rate of change of velocity. The kids on the bus hate related rates, hate related rates, hate related rates. The kids on the bus hate related rates. The pain scale of 8. The kids on the bus think about the AP test, about the AP test, about the AP test. The kids on the bus think about the AP test. Will they get a 5? The calculus concepts intertwine, intertwine, intertwine. The calculus concepts intertwine, exploring math oh so fine.
If you like areas and you know it, find the integral. If you like areas and you know it, find the integral. If you really like areas and you really want to show it, if you really like areas, find the integral. If you really like areas, find the integral. If you want the area, top minus bottom. If you want the area, top minus bottom. If you really want the area and you really want to show it, if you really want the area, top minus bottom. If you really want the area, top minus bottom. If you like volumes and you know it, use shells. If you like volumes and you know it, use shells. If you really like volumes and you really want to show it, if you really like volumes, use shells. If you really like volumes, use shells. If you like volumes and you know it, use discs. If you like volumes and you know it, use discs. If you really like volumes and you really want to show it, if you really like volumes, use discs. If you really like volumes, use discs. If you want to use discs, pi r squared. If you want to use discs, pi r squared. If you want to use discs and you really want to show it, if you want to use discs, pi r squared. If you want to use discs, pi r squared. You want to use shells, 2 pi r h. If you want to use shells, 2 pi r h. If you want to use shells and you really want to show it, if you want to use shells, 2 pi r h. If you want to use shells 2 pi or h, if you want the area or volume, you have to integrate. If you want the area or the volume, you have to integrate. There's no way around it, area or volume. If you want the area or volume, you have to integrate. If you want the area or volume, you have to integrate.